Hey bio students, this is Guy from PengPrep.com. Welcome to video 2 of Chemistry Stuff to Know. If you recall, atoms are only stable when their valence electron shell is complete, and atoms can either gain or lose electrons to achieve that stability. Now, there's a measure for how much an atom wants to gain an electron to achieve stability. It's called electronegativity. Electronegativity is governed by two factors. One, the number of protons. Two, the number of electron shells. Now, protons are positively charged, so the more there are, the more positively charged the nucleus will get. And this attracts the surrounding electrons more strongly, meaning that the atom will be more likely to gain an additional electron. Now, electrons are negatively charged, so they prevent other electrons from coming close to the nucleus. So the more electron shells there are, the more difficult it is for the atom to gain an additional electron. Now, one thing to know though is that the addition of a single electron will have a minimal effect on the electronegativity of the atom. It is the addition of an entire shell that will reduce the electronegativity of that atom. Using these two rules, let's compare the electronegativities of carbon and nitrogen. Carbon has 6 protons and 2 shells. Nitrogen has 7 protons and 2 shells. Now, the number of shells are the same, so the repulsive forces due to the electron shells for both elements is going to be roughly the same. Now, nitrogen has 1 more proton than carbon. This means that its attractive forces are going to be stronger than carbon. Since both elements have the same amount of repulsive force, but nitrogen has a greater attractive force than carbon, nitrogen has a stronger tendency to attract an electron. Hence, nitrogen has a greater electronegativity. Now, I want you to compare the electronegativities of oxygen and nitrogen yourself. Oxygen has 2 electron shells and 8 protons. Nitrogen has 2 electron shells and 7 protons. Since both elements have the same number of electron shells, their repulsive forces are roughly the same. Oxygen, however, has 1 more proton, meaning that its attractive forces are stronger than nitrogen. Therefore, oxygen has a greater tendency to gain an electron and has a greater electronegativity. Do you see the pattern? When we go from left to right on the same row, the electronegativity of the atom increases. This is because the number of electron shells remains the same, while the number of protons increases as you go from left to right. What if we go from top to bottom, not left to right? To illustrate this, I'll compare the electronegativities of oxygen and sulfur. Sulfur has 8 more protons than oxygen does, so it has a stronger attractive force than oxygen. But sulfur also has 1 more electron shell than oxygen, meaning that it also has a stronger repulsive force. So this means that if the repulsive force gained by an additional electron shell is less powerful than the attractive force gained by 8 protons, then sulfur's electronegativity will be greater than oxygen. But if the electron shell is more powerful than the 8 protons, then sulfur will have a lower electronegativity. Well, it turns out that the repulsive force gained from an additional shell is much stronger than the attractive force gained by 8 protons. This makes it more difficult for sulfur to attract electrons, and hence, the electronegativity of sulfur is less than that of oxygen. Now, I want you to do it yourself. Pause the video and complete the following questions. Why do molecules exist? Why can't atoms just stay alone as atoms? Well, it's because most atoms by nature are unstable. They have an incomplete valence shell, so they'll look for partners to either donate, receive, or share electrons with. For example, sodium has 1 valence electron, and chlorine has 7 valence electrons. Sodium is better off losing an electron, while chlorine is better off having 1 more electron. So sodium can donate its electron to chlorine, making both of them satisfied. And in the process, they form a linkage called a bond. A bond is a link that connects 2 atoms, and it's formed when 2 atoms donate, receive, or share electrons. There are 2 types of bonds that you should know. One is an ionic bond, which is formed from donating and receiving an electron, like sodium and chlorine. The other is called a covalent bond. Let me show you an example of a covalent. Let's say there are 2 chlorine atoms. Each will have 7 valence electrons, and each will want 1 more. Now, transferring an electron won't work here because one Cl atom will be satisfied at the cost of another. But if these 2 Cl atoms can share 2 electrons, then both can be satisfied, as shown in the visual. Whether an electron is donated or shared, that is whether 2 atoms form an ionic or covalent bond, depends on the difference in electronegativities of the 2 atoms concerned. When the difference is large enough, the 2 atoms will form an ionic bond. And this often happens between metals and nonmetals. But when the difference is not significant, like between 2 nonmetals, they will form a covalent bond. Now, let's try classifying the type of bond that's formed between the atoms in the following molecules. O2 is formed from two oxygen atoms which are both non-metal, so the bond between the two oxygen atoms is covalent. CaCl2 is formed from a calcium atom, which is a metal, and two chlorine atoms which are non-metals, so the bond between a calcium and a chlorine atom will be an ionic bond. H2O is formed from two hydrogen atoms which are non-metals and an oxygen atom which is also a non-metal, so the bond formed in between them will be covalent. Now let's talk about covalent bonds more deeply. Electrons shared between two atoms will be influenced by the attractive and repulsive forces of both atoms. When there's a more electronegative atom, it will pull the electrons more strongly towards itself, resulting in those shared electrons being more closer to that more electronegative atom. This results in an uneven distribution of charge. The side with the more electronegative atom is going to be more negative compared to the side with the less electronegative atom. When a molecule has an uneven distribution of charge like this, we call it polar. H2O is an example of a polar covalent molecule. Hydrogen has a much lower electronegativity compared to oxygen, so oxygen will pull the shared electrons more closely towards itself. As a result, the side with oxygen is going to be more negative compared to the side with hydrogen. Normally, any two distinct nonmetals on the periodic table will have electronegativities distinct enough to create a polar covalent molecule. However, one exception is between carbon and hydrogen. These two atoms have such similar electronegativities such that although they are different nonmetal atoms, the molecule formed from them, like CH4 or C2H6, are considered nonpolar. As you would expect, a molecule formed from two identical atoms, like O2, are not going to be polar molecules because there's no uneven distribution of charge. Now, I want you to try and classify each molecule as polar and nonpolar. Now, I want you to think about a cup of water, 250 milliliters. There are 8.4 septillion water molecules in that thing. So why are they not drifting away? What's keeping them together? Intermolecular forces are keeping them together. Intermolecular forces are the forces between molecules. Now, why do these exist? Well, I want you to think about water molecules in a container. These water molecules are polar, so they have a positive and negative side. Now, the positive side of a water molecule can be attracted by the negative side of another water molecule. And these connections, innumerable connections, make these water molecules attract each other and keep them together. Every fundamental that I covered so far was so that you can understand this idea of intermolecular force. Here is the full mechanism that you should be able to recite. First, atoms are inherently unstable because they have an incomplete valence shell. Second, to achieve stability, atoms form bonds and molecules by either sharing or donating electrons. Third, molecules formed from covalent bonds can be polar because of an uneven distribution in charge caused by the different electronegativities of the constituent atoms. Fourth, two polar molecules will attract each other, an idea known as intermolecular force. That's it for chemistry fundamentals. Practice problems are uploaded on pengprep.com with the link in the description below, and from the next video, we'll talk about the properties of water. I'll see you then.